In this video we shall discuss how to use stored functions for data operations. In the first task we have to create a stored function that receives a subscription start and end dates and returns the difference in days, along with suffixes. And those suffixes should be like this if the difference is less than 10 days, like this if the difference is between 10 and 30 days, and like this if the difference is more than 30 days. The expected result is that this column should be produced by our function. Also, please notice that this value is not a bug, because this is the start value, this is the end value, and you may refer to that topic for details. The solution for MySQL is the next. We have to create such a function, we have to pass the start and the finish date into the function. Then inside we have to declare two variables for dates difference and suffix. Then we have to calculate that dates difference, and based on that difference we have to detect the suffix. And on the final step we have to concat this string and that string and return the result. To test this function we have to execute such a simple query. Here is our function call and this is the result. Let's continue with Microsoft SQL Server, and we have to emphasize that we use the same approach for each DBMS. The only difference is in the syntax details. So once again we have to create such a function, we have to pass the start and the finish date into the function, then we have to declare variables for dates difference and for the suffix, then we have to calculate the dates difference and we have to calculate the suffix based on that dates difference. And finally we have to concatenate these two strings and return the result. To test this function in Microsoft SQL Server we have to execute such a query, and this function call produces us the following result. Obviously the solution for Oracle is the same. We are creating such a function, we are passing the start and finish date into the function, then we are calculating the difference between the finish and the start dates, then we are calculating the suffix based on the difference, and we only have to concatenate these two strings and return the result. And to test that function in Oracle we have to execute this query, and this function call will produce this column. In the second task we have to create a stored function that returns empty values of a primary key of a table. So imagine a table that has such values for primary keys. Then our function should return these values as empty keys. The expected result will depend on the DBMS and its capabilities. And it may be a table with empty range start and empty range end columns, or it may be a table with single empty keys column, or it even may be a string with all empty keys values. Before we start reviewing the solution for MySQL, we have to emphasize that this DBMS has two limitations. The first limitation is that dynamic SQL is not allowed in this DBMS in stored functions. That's why we may process only one predefined table. And the second limitation is that MySQL does not allow to return tables from stored functions. That's why we may return only strings here. Now let's look at the solution. Here we are creating our function, we are declaring several variables, and this variable is the most interesting one. This is a cursor, it is a specific structure that allows us to iterate through the result of an SQL query. The SQL query itself produces the following result. This part reacts to some values somewhere in the middle of the initial table. For instance, imagine that it detects the 3 value. It takes that value, adds 1, and that's how we get this value, this beginning of the range of an empty keys. Then it looks for the next minimal value, here it is, 42. Then it decreases it by 1, and that's how we get this end of the empty keys range. And this part reacts to situations when the range has only the ending but not the beginning. So here it produces this pair of values. Then we have to open the cursor, we have to start executing the query, and we have to iterate through values produced by that query. This part allows us to detect have we reached the end of the data produced by the query, and if we did, we shall leave the loop. Inside the loop we have to produce intermediate values. For instance, if the beginning is 3 and the end is 7, this part should produce 4, 5, 6 values here. Finally, we have to remove the trailing comma in this string, and then we only have to return our final result. To test our function, we have to execute such query, and that query will produce this result. Let's continue with Microsoft SQL Server. This DBMS also does not allow to execute dynamic SQL inside stored functions, so we only may process the predefined table. But unlike MySQL, Microsoft SQL Server supports table-valued functions, and that means that we can return a table from a function. And that's why the solution is so simple. We are creating our function and we only executing that query to produce this result. This query is exactly the same as for MySQL, but if in MySQL it was an intermediate result, here it is the final result and we are returning this table. To test our function in Microsoft SQL Server, we have to execute such a simple query, and obviously we shall get such a result. With Oracle, a good surprise waits for us. There are no both limitations here. It is, unlike MySQL and Microsoft SQL Server, Oracle allows dynamic SQL execution in stored functions. And unlike in MySQL, Oracle supports tabled value functions. It is, we may return a table from this function. While the solution is rather simple, there are some syntax specifics. First, we have to create a data type consisting of two numeric values for start and stop values of the empty keys range. Then we have to create a table, each row of which will be that data type. Then we are creating our function and we are passing the table name and the primary key name as parameters. Then we have to declare some variables, and here is the most interesting part. Here we're composing a string, and that string consists of some SQL code and the information about primary key and information about table name, and that information was passed to our function as parameter. Then we have to open a cursor for such final query, and we have to copy the information from this query result to our final table. And then we only have to return our final table. And here it is. To test this function in Oracle, we have to execute such query. Here is our function call, and that's the transformation of the returned data into such a table. In the final task, we have to create a stored function that updates book statistics table and returns the delta of registered books count. Please see this topic of our course for details. Obviously, the expected result is that after the function call, the data in book statistics table should become up to date and the function should return the delta of registered books count. Let's start with a quick recap from the corresponding topic of our course. We have to create the table, we have to clear the table, and we have to initialize the data in the table by this query. And here is the solution itself. We have to create a function. Inside that function we have to select the initial data about books count. Then we have to update the table by such query. Then we have to select the new books count. And the only thing left is to subtract the new books count, the old books count, and return the result. To test this function, we have to execute such a simple query, and obviously to see anything but 0 here, you'll have to modify books and/or subscriptions tables data and run this query again. Let's proceed with Microsoft SQL Server. Unfortunately, this DBMS does not allow modifying data with stored functions, so this task has no solution for this DBMS. And so we are immediately proceeding with Oracle and starting with a quick recap. Back in that topic, we've created a materialized view in Oracle, so we have to drop it here first. Then we have to create the table, we have to initialize the table with this data, and then we are following the same approach as with MySQL. It asks we are selecting the initial books count, we are updating the table, we are selecting the new books count, we are subtracting the new books count and the initial books count, and we are returning the final result. To test this function, we have to execute such query, and obviously to see anything but 0 here, you'll have to modify books and/or subscriptions tables data and run this query again.